Assalamualaikum and good day. My name is Abdul Arif Fikri Bin Ismail and I'm a semester 8 student, and today I will be presenting my final year project 2 presentation titled The Investigation on Transformation Induced in Process Chain of Forming to Welding Using Simulation and Experimental Study. So my supervisor is Professor Yupiter Manurung and my co-supervisor is Mr. Mohd Shahar bin Sulaiman. So we start with the introduction. So moving along with the Industrial Revolution, manufacturing sector needs to be in sync with the technological growth and the expansion by utilizing new technologies such as the virtual manufacturing. So virtual manufacturing enables the enterprise to evaluate the productivity and the affordability of new product or process concept with respect to the risk, their impacts on manufacturing capabilities, production capacity, and their cost. So virtual manufacturing aims at providing an integrated environment for a number of isolated manufacturing technologies, such as the computer-aided drawing, CAD, computer-aided manufacturing, computer-aided process planning, thus allowing multiple users to concurrently carry out all or some of the process without the need to be physically close to each other. So the finite element method is the most largely used method for solving problems of engineering and mathematical models. To solve the problem, it subdivides a large system into a smaller, simpler parts that are called finite elements. A deterministic finite element simulation of manufacturing process chain is another approach to evaluate the manufacturing process and the properties of final assembly. And next, the chaining of the finite element simulation was realized by mapping the result from each previous step onto an finite element mesh based on the nominal geometry prepared for the welding simulation specifically. So the problem statement for this study, there are two main problems, which are the spring back occur during the forming process and the distortion occurs during the welding process. So for the spring back, it occurs when a metal is bent and then it tries to return to its original shape, which a large amount of force is applied to the workpiece in the bending process that causes the worksheet to experience a geometrical change when the workpiece has been released from the forming tool, which for this study is the die set. And then for the distortion during the welding process, the weld element will experience a complex change in temperature that will cause a transient thermal stress or the distortion, and the joint are prone to experience shrinkage as the heated method cools over time. And so the spring back and distortion both can affect the quality and the accuracy of the final end product. And both of these problems cannot be completely eliminated as it is a natural occurrence, but it can be controlled and minimize the effect. So the objectives of this study is to analyze the spring back and the distortion induced by the procession of forming to welding. Next, to find the optimum parameter for procession of forming to welding using the Simulfact forming and Simulfact welding, which are the finite element software. And lastly, to compare and verify the results obtained from the simulation with the experimental results. Next, we move on to the scope of work for this study. We will analyze the spring back and distortion induced by the procession of forming to welding. The project will use the material a low carbon steel GC04 with the dimension of 92 mm times 70 mm with having 2 mm thickness. And the forming and welding parameter used in the experiment will be used in the simulation, such as the forming stroke, the forming speed, weld speed, the welding voltage, and the welding current. And we will conduct the simulation for forming and welding process using the finite element software, Simulfact forming and Simulfact welding. And the forming and welding experiment conducted to produce result that will be used to verify the simulation result to show the reliability of finite element software. Next are the methodology. The methodology start with the literature review. The literature review consists of section which we will extract information from a previous study, such as a research journal. So for this study, we extract heat transfer coefficient from one of the journal. And next, we will do the experimental setup which we will set up the experiment for forming and welding process and conduct the experiment. For the simulation parameter, the parameter will be replicated the same with the parameter used in the experiment for forming and welding process. And next, we will run the finite element analysis by doing the simulation. And then the result will be analyzed and discussed and proceed with thesis writing to complete the research. For forming experiment, a 2mm low carbon steel DC04 is cut into 92mm times 70mm dimension. So the forming process is done by using the Instron MTS 3382 hydraulic press in the Strength of Material Lab, UiTM Shah. So a die set will be installed under hydraulic press, which are specifically the upper die. And the die set will produce a U-shaped bend workpiece, and the forming process parameter are as below, which the stroke is set at 15mm and the forming speed is set at 5mm per minute. And next, for the welding experiment, so the bend workpiece from forming process is stacked manually using the gas metal arc welding manually with a 0.5mm gap to form a temporary joint before welding with the robot. And the process is completed using the robot welding Kempi Pro MIG 120R at the Advanced Manufacturing Lab, UiTM Shah. So the welding trajectory is set along the bend workpiece to join the two workpieces together, and the workpiece is hold still by applying the clamp on both ends, and the welding process parameter can be shown as in the table, which the current used is 107 ampere, 16 voltage volt, 5mm per second speed, and the wire feed rate is set at 3mm per second. So next is the coordinate measuring machine, CMM. After each forming and welding process, the spring back and distortion effect is measured using CMM. So as we know, CMM can provide a more accurate measurement. So the deformation is recorded to be compared with the simulation. So CMM is done using the Mitutoyo Beyond 707 model, and the workpiece is placed on a flat datum steel bar to ensure a really flat surface, and the workpiece is clamped to avoid any movement during the measurement process. Moving on to the finite element method, the forming simulation. So the procession is designed using the finite element method, which for the forming process, Simulfact forming software is being used. So the Simulfact forming sheet metal bending simulation process flow can be described as below, which the die and workpiece modeling is designed using CATIA software, which are the computer aided drawing CAD software. And the die and workpiece geometry will be imported to the Simulfact forming software using a STL 3D format. And then we will assign the material to the workpiece, which are the DC04, which can be obtained from the Simulfact material library. And next, we will set the friction parameter and assign to both upper die and lower die. And we will assign the temperature for die and workpiece, for which in this process, a 220 degrees Celsius is set, which a temperature nearby to the room temperature. And then the most important detail of the finite element method is the mesh, which we will set the mesh according to the element size and the thickness of the workpiece. And then we will set the forming speed and the forming stroke. The forming stroke and speed we will assign to the upper die on the hydraulic press. And then we will run the simulation and analyze the results. As we can see here, the forming simulation setup can be seen on the right picture, which consists of 3 geometrical modeling, which are the red geometry is the upper die, the cyan color geometry on below is the lower die, and then on the middle is the workpiece, 2mm DC04 workpiece. So the forming simulation parameter is as below, which for the coefficient of friction, 0.3 of column friction is being used, and the hydraulic press is set at 5mm per minute speed for 15mm stroke. So for the mesh modeling for workpiece, 1.3mm per element size is being used, and by 2mm thickness is divided into 4 elements. And then the die and workpiece temperature is set at 20 degrees Celsius. So the second stage of forming to welding processing is the welding process, and the finite element method software Simulfrac Welding is being used for this process, and the process flow can be illustrated as shown. So the welding type is selected, and which for this process gas metal welding is selected, and we will assign the numbers of welding components, the bearing, clamp, and the robot. Next, we will import the bend geometry from Simulfrac forming project, and then we will import the material from Simulfrac material library, which are the same material DC04, and DC04 will be used for the workpiece material and also the filler material for welding process. And then we will generate the bearing below the two bend workpiece, which the bearing will act as welding table. And then we will set the gap between the two workpiece with 0.5 millimeter gap. And the node set will be generated along the bend workpiece. And to further explain, the node set will be declared as the weld line or weld trajectory, and it will be assigned to the welding robot. So the heat transfer coefficient is set, and the welding parameter is also generated. The heat source parameter is be set according to the experimental data, which we will follow the Goldach double ellipsoid heat source model. And next, the welding trajectory is aligned 90 degrees with the surface, and the filler is generated along the welding trajectory. And then we will run the simulate, and the solver is set, which time is added for cooling process, and then we will run the simulation and analyze the results. So for the welding simulation, these are the heat transfer parameter, which consists of the general temperature 20 degrees Celsius, the convective heat transfer coefficient, contact heat transfer coefficient, and the emission coefficient of 0.6. And below are the Goldach double ellipsoid heat source model parameter, which shows the frontal length of 2.5 mm, rear length of 5 mm, 2.5 mm width, and 3 mm depth. And on the right is the Goldach heat source model. So in Simulfrac welding, the imported geometry is set to be aligned with the gap of 0.5 mm. And on the right, it can be seen as the model is complete with two clamps on each side. The clamp is set with 1000 Newton of force in negative Z direction. And the welding trajectory is set, and the welding trajectory is always 90 degrees with the surface, as it can be seen with the arrow projected on the model. And under the bend workpiece is the welding bearing, which act as the welding table. So for the welding simulation, weld filler is one of the most important detail, which for this simulation, the weld filler is generated by using the fillet geometry parameter in Simulfrac welding robot settings. So the weld filler is generated according to the following parameter, which having 1.7 mm throat length, negative 0.2 bow length, and the leg 1 and leg 2 having the same length, which are 2.4 mm. And it can be seen in the image. The image show the welding fillet example preview. Moving on, these are the welding simulation parameter, which consists the same parameter used in the welding experiment, which are the 5 mm per second speed, 107 ampere of current, 16 volt of voltage, and there are 85% efficiency used and set in the welding simulation. So this for the result and discussion. So the result and discussion is divided into two sections, which are the springback due to the forming process and the distortion due to the welding process. So for the first section, the springback, the forming process was conducted in both experiment and simulation. So the forming process simulation experiment is steered with the same parameter, and logically it should produce the same or likely result of one another, but the compressive force produced for forming process in the experiment and simulations is quite different, which for the experiment, the compressive force at 15 mm stroke is located at 105 kN, while the simulation is located at 140 kN. And this is the preview of forming process, which I will demonstrate in the video. These are the forming process with 15mm stroke, and these are the results of the effective stress. And next, these are the preview image for experiment and simulation result, which are on both edge. We can see a slight deformation, which are the spring back. And to further explaining the result, the experimental result obtained by measuring a 6 point on each edge of the workpiece by using CMM. And both experimental and simulation result will be compared at the same point to observe the increment from the initial flat point. So these are the results for the 6 point, which the percentage of error ranges from 18% to 34%. So the second part is the distortion due to the welding process. The forming to welding process chain illustrate the result transfer process that occurs between forming to welding process, whether in the experiment or simulation. So the welding produced an Excel result in which the two bend workpieces are joined successfully. The distortion effect of welding can be seen as the welded specimen does not hold a perfectly straight model, which the welded specimen is due to a minor distortion on the weld build area, as you can see in the image. And these are conducting the gas metal arc welding experiment of the two bend workpiece. The parameter is being replicated to run the Simulfact welding simulation to simulate the welding process, and it can be seen in the video. These are the temperature distribution, which shows the welding process. The welded specimen is then measured with the coordinate measuring machine, CMM, to further identify the distortion and deformation caused by the extreme welding temperature. So the distortion result from Simulfact welding is exported out for the result to be tabulated, and there are 10 tracking points involved during the welding simulation, as we can see in the image below. The distortion post-welding process for the experiment ranges from 0.141mm to 0.744mm, while in the welding simulation, the distortion is placed between 0.118mm to 0.472mm. So these values of increment are compared in a table, which the maximum error produced is at 0.6, which are the 36.49%, which are logically presented, which 0.6 is located at the end of the weld bit, which experience cooling process and produce the highest distortion. So for conclusion and recommendation, so to conclude the study, the simulation and experimental analysis for both processes in which was linked with the result of this research. So the simulation analysis is done with the aid of finite element software, the Simulfact forming and the Simulfact welding. So the finite element analysis of forming and welding process were completed successfully, and the process is well defined. And the final output of the simulation with the aid of Simulfact forming and Simulfact welding proves a good comparison with the experimental results. Focusing on the welding experiment, the simulation managed to produce a reliable result in context of the total distortion effect of the specimen after experiencing forming and welding process. And next, the result variance between simulation and experimental may be caused by the geometry, the non-homogeneous material, the result transfer in between process chain, and the parameter instabilities throughout the process. So the finite element method could prove the information needed, and it can be used to plan and design a forming or welding process before executing an actual process. So for the recommendation, the study may contribute to an advanced development in virtual manufacturing and its reliability to model an actual process, in which we can save the cost and time. And next, the addition of well temperature distribution data throughout the process to monitor the peak and the minimum temperature area along the weld line, which can be related with the temperature effect to the distortion. This is my student information. My name is Abdul Arif Fikri, and this is my student ID, my email, and my contact number. I can be contacted on both platforms, and thank you.